Hi guys, Algebra 1 students. We are going to do lesson 3-5 today, graphing linear equations in slope-intercept form. So grab you some notebook paper, put your heading on there. Remember, you can pause the video at any time to review, finish, or go back over some things. Let's go ahead and get started here. So I want you to spend a few minutes on the warm-up thinking about how you would graph the following equations in a coordinate plane. Now look at the form of the equations and think about previous lessons and how we graphed those standard form equations. Remember, you can pause the video. Okay, so looking at number 1, I have 2x plus 5y equals 10. If I were going to graph this equation in standard form, I would use my x and y intercepts. So let's find our x-intercept first. So if you'll recall, when we are locating our x-intercept, we're going to substitute a 0 in place of our y value. So I'm going to put 2x plus 5. Now I'm going to replace the y with a 0 equals 10. Any value times 0 is 0, so that leaves us with 2x equals 10. Divide both sides by 2, and x equals 5. So the coordinates for my x-intercept would be 5, 0. Now, thinking about the same concept for my y value, and I'm just going to go right above here for my y-intercept. My pen is horrible, sorry guys. I'm going to substitute a 0 in place of my x value. I'm using the same equation. So I'm going to go through the same process now, replacing the x value with 0. So 2 times 0, 0. 5y equals 10. I'm going to divide both sides by 5. And y equals 2. So my ordered pair for my x-intercept would be 0, 2. So I'm going to place both of those on the graph, and then I will have my line. So my x-intercept is going to cross at 5. 1, 2, 3, 4, 5. So I'm going to put my point there. My y-intercept is going to cross at 2. So I have my 2 points. Now I can make my straight line. Not so straight line there. Sorry. I think I can do a little bit better than that. So let's put a point at 5. Another point at 2. And this time, I'm going to attempt to make a better line. So that one looks a little better. Okay, we're going to go through the same process for number 2. So again, we're going to find our x-intercept by substituting a 0 for y. So we have our standard form equation for x. Subtract 5. I'm going to replace the y with 0 and set it equal to 20. Go through that process. Now we have 4x equals 20. Divide both sides by 4. And x equals 5. So my coordinates for this x-intercept would be 5, 0, And we're going to go through the same process for our y-intercept. So I'm going to replace now my x with 0. So we have 4 times 0, subtract 5y equals 20. Now we're left with negative 5y equals 20. Divide both sides by negative 5, and y equals negative 4. So my ordered pair or coordinates for my y-intercept would be 0, negative 4. Now I'm going to place that on my graph, my y and my x-intercept. So my x-intercept is at 5, 0. And my y-intercept is at 0, negative 4. Okay, now I'm going to connect those. And put arrows at both ends there. And I've graphed both of these standard form equations with my x and y intercepts. Okay, we have some vocab now. Let's talk about a slope. And actually, we've talked about slope a few times before. One definition for slope is the rate of change between any 2 points on a line, sometimes referred to as rise over run. Rise is referring to our y value, and run is referring to our x value. Our next vocab is rise, change in y. Now remember, when we're finding the change in math, we will subtract, which allows us to find a change or difference. Okay, next we have run. Run is the change in our x value. And again, if we're referring to change in math, we're talking about the operation subtract because we're finding a difference. Okay, now with that in mind, let's talk about our slope. Okay, is always referred to as m, which is the same thing as rise over run, what we just talked about. The change in y divided by the change in x, or you can think about it like a ratio or rate of change. The formula to calculate slope when we have two sets of ordered pair is y sub 2 subtract y sub 1 divided by x sub 2 subtract x sub 1. Now those values down below, the x and the y, are called subscripts. They're just for identification purposes. We're not going to do any math with those. That just allows us to identify which set we are working with. So if I have set 1, and let's say I had the ordered pair 0, 2, and I had another ordered pair I could refer to as set 2, that would allow me to identify which sets and values for x and y that I'm going to subtract. So it's just for identification purposes. This diagram down here at the bottom that I'm pointing to now is showing you an example of what this would look like on a coordinate plane. So rise is going to refer to the change in y. That's going to be on our y-axis. And run is going to refer to our change in x. That is our horizontal axis. Okay, 4 things that we need to know for certain about slope. The first example is referring to a positive slope. You read slope from left to right on a coordinate graph or plane. So with a positive slope, the line will rise from left to right. Now the level of increase can vary, so keep that in mind as well. With a negative slope, the line falls from left to right, so it decreases or drops as you read the graph from left to right. A slope of 0 is a horizontal line. There's no increase or decrease, it's remaining steady. An undefined slope has a vertical line. Undefined in math means you cannot define it. So technically it doesn't exist. So if we have a vertical line, we have an undefined slope. Now, if you'll remember the slope, the video that we watched about Mr. Slope Guy, his eyebrow, I should say, was a positive slope. His other eyebrow was a negative slope. His nose was a vertical line telling us undefined. And his mouth was a horizontal line with a slope of 0 on both ends. Okay, let's talk about example 1. Example 1 says describe the slope of each line, then find the slope. Now we've got some methods here, some strategies that we can use. And first of all, I'm going to show you the strategy with the slope formula. So if you didn't write it down earlier, you might want to make note of your slope formula. You're going to use it repeatedly. So m equals the change in y over the change in x. So if I have 2 ordered pairs, then I can label those ordered pair and substitute them into the slope formula. So let's look at our ordered pair here that we have. We have a -3, -2, and we have a 3, 2. So if I took this first ordered pair, -3, -2, and I took my next ordered pair, +3, +2, and I labeled those x1, y1, x2, y2, I could substitute them into the formula and calculate my slope. So let's practice substituting those into the formula and talk about what that would look like. So I would take my y2, which is 2, and guys, you must do it in the correct order. So if this is my set 2, I have to use this y and I have to use this x as set 2. So I have my y2, subtract y1. y1 is -2. Also make sure if it's a negative that you're using the sign. Just some people put in 2 subtract 2 and call it good, but it's not. It's really 2 subtract -2. That's going to change our value there. Now we're going to take our x coordinates, x2, which is 3, subtract x1, which is -3. And you can put those in parentheses if you prefer, but make sure you're using your negative signs as well. And you can put that directly into a calculator if you need to. So when I go to calculate my slope, 2 subtract -2 really means 2 plus +2, which is 4. And 3 subtract -3 translates to 3 plus +3, which is 6. Now, if you're doing this work in the calculator, it'll automatically simplify this for you to 2/3, which is what you need in slope. Slope must always be in simplest form. So another positive for using the calculator, it simplifies for you. Now I'm going to show you another strategy, and that is if you have a graph, you can count slope. So this first point over here on the left to this second point over here on the right, I'm going to count from the left point to the right point. And I'm going to see what's going on in my y compared to my x, just like I calculate the difference in slope. So we're using the change in y compared to the change in x. So if I were just counting, and I counted from the left point to the right point, that is up how many units? 1, 2, 3, 4. So that's a change of positive 4 units, or just 4. And over x is counting over 6 units. So that's a change of positive 6. So 4/6 simplifies to 2/3. And I did that just by counting from the left point to the right point on the graph, which they had those values for us already. I was just showing you the process that you go through to count. So when it says describe the slope of each line, then find the slope. A, we can tell it's a positive slope because it's increasing from left to right, and we can calculate that by using the slope formula and substituting our ordered pairs, or by counting the change in y from the point on the left to the point on the right over or compared to the change in x, and then make sure it's in simplest form. Okay, let's talk about example B now. So if I were taking my ordered pair and I were going to use the slope formula, I would call set 1, 0, 2, set 2, 2, -1. And remember, it really doesn't matter which one I call set 1 or set 2. The only thing that has to be consistent is whatever I choose to call x1, that also has to be y1. And whatever I choose to call x2, the y value has to be y2. Okay, so now we're going to plug these into the slope formula, and I'm just going to come right over here, and I'm going to take y2, which is -1, and I'm going to subtract y1, which is 2. I'm going to write that over x2, which is 2, subtract x1, which is 0. And then I can put that directly into the calculator, or I can go ahead and solve with my rules for adding and subtracting with integers. -1 subtract 2 actually turns it into -1 plus -2, which is -3. And 2 subtract 0 is 2. And if you did it in the calculator, it will tell you that this is in simplest form. So this slope is -3/2. Now we can go through the same process because we do have a graph, and we can count from this point on the left to this point on the right. Remember, we're counting the change in y first. So from this point on the left to this point on the right, it is going down 3 units. So a movement down 3 represents a -3 over 2. So again, we have the same slope, -3/2. And describing the slope just means it is a negative slope. Calculating or finding the slope, our slope is -3/2. Okay, example 2, finding slope from a table. The points represented by each table lie on a line. How can you find the slope of each line from the table, and what is the slope of each line? Now, previously we used the slope formula to calculate the slope, and we can actually do that again if I have tables of ordered pairs. So remember, we're taking y sub 2, subtract y sub 1, over x sub 2, subtract x sub 1. So we're finding that ratio or rate of change. So if I'm looking at this first table, table A, and I wanted to set up some ordered pair, it really doesn't matter which ordered pair I choose to use. I'm just going to take the first two, and I'm going to call this first one set 1. So I'll have my x1, my y1, x2, y2. So now I'm going to put those in place in the equation, and I'm going to simplify that, or formula. So y2 is 14, subtract y1, which is 20, and then x2 is 7, subtract x1, which is 4. You can put all of that into your calculator, and it will simplify it for you, or you can calculate the top, the bottom, then simplify. It doesn't matter. On the top we get a -6, on the bottom we get a +3, which simplifies to -2. So how can you find the slope of each line from the table? By using the slope formula. And then what is the slope of the line? For table A, we have a slope of -2. Okay, let's move on to table B, and we can create an ordered pair here. Now, if you glance at table B, you might notice something about the y, or the output values. They're actually the same. There's no change happening in y. Now, if you're not sure what that means, go ahead and use the slope formula and calculate the slope and see what that means, noticing that there's no change in y. So I'm just, again, going to call this set 1. So x1, y1, x2, y2. Now, if you want to write them differently away from the table, that's perfectly fine. Go for it. So y2 is 2, subtract y1, which is 2, over x2, which is 1, subtract x1, which is -1. So 2 subtract 2 is 0, and 1 subtract -1 is actually 2. And 0 divided by 2 is 0. So if I have a slope of 0, that means the change in y is 0. So anything with a slope of 0, if I were to graph this, would be a horizontal line. And notice it's passing through every y value is 2. So that verifies that, yes, it would be a horizontal line. Okay. Table C. Again, we're going to do the same thing. And if you've noticed in table C, our x values are the same. So wonder what that might mean. Let's use our slope formula, and let's go ahead and calculate our slope and see what that might mean when all of our x values are the same. There's no change happening in x. So I'm going to take y2, which is 0, subtract y1, which is -3, and then I'm going to take x2, which is -3, and subtract x1, which is -3. So up here we actually end up with 3, and on the bottom we actually end up with 0. And division by 0 is, if you put it in your calculator, it's going to give you that message, Division by 0 is undefined. So our slope in table C is undefined. And what kind of line has an undefined slope? Vertical. So we have a vertical line if we were to graph those values in table C because our slope is undefined. Okay, another core concept here, slope-intercept form. We talked about standard form previously. Now we're going to talk about slope-intercept form. So with slope-intercept form, we have a linear equation written in the form y equals mx plus b is in slope-intercept form. The slope of the line is m and the y-intercept of the line is b. Now previously, I've mentioned that one way to remember this, m stands for how we move, and b represents where we begin. And that's when we start graphing in the slope-intercept form. So just a way to remember that. And of course, our x and our y are just our x and y coordinates. Now, one other note to mention, B, if you'll recall, is our y-intercept. So that's the point where it's going to cross the y-axis. It could be a positive if it's above the 0 on the y-axis. If it's below the 0 on the y-axis, it could be a negative value. So depending on where it's located, your B could be plus or it could be subtract. Okay, definition. Slope-intercept form. Slope-intercept form, also known as SIF acronym, an equation written in the form y equals mx plus b. Remember, m is our slope and b is our y-intercept, where we cross the y-axis. Our x and our y are just our ordered pair values. Okay, let's go on to example 3 now and apply that slope-intercept form. So if we're talking about slope-intercept form, remember we're talking about y equals mx plus b. So keep that in mind because we need to find the slope and the y-intercept of the graph of each linear equation. So if I want to look for each of these parts, I can look and see this first equation in A is pretty much set up exactly as slope-intercept form. So if I need to know what the slope is and the y-intercept, I can basically look at the parts of the graph. So my y-intercept is -4 and I have a slope of 3. So again, I'm going to use my m and my b to identify which one is which. So my slope is 3. My y-intercept is -4 because there's subtraction going on in the equation. Okay, same thing with b. We're looking to see if this matches the slope-intercept form equation. Now, b is a little different. What do you notice about the equation for b? Do we have all of the values or all of the other parts in there? No, we just have y equals 6.5. So if I just have y equals 6.5, that tells me a couple things here about this equation. This equation is something called a constant function. So this is an example of what we call a constant function. The equation can also be written as y equals 0x plus 6.5. So that might give you a little bit more information about this equation that looks a lot different than the slope-intercept form. So with that in mind, can you tell me what my slope is now? Okay, my slope is 0, and my y-intercept is 6.5. Okay, let's look at C. So on C, if you'll notice, when we look at that equation and try to think about slope-intercept form, we do not have an equation in slope-intercept form. We can get there, though, if we move a couple things around. So if I were to think about this in terms, I have 3 terms here. And we've done this in the past. If you break those terms apart, there's 3. So if I want to get that y equals by itself, like this slope-intercept form, I'm going to have to move this negative 5x. Now I can combine it with its opposite, or I can think about the rule, move it across the equal sign, change the sign. Same thing, same process. This allows me to cancel out or make a 0 pair. Now we have a negative y equals, and I'm going to go ahead and write my 5x before my negative 2 because my goal is to get it to slope-intercept form. And I can put it in that order. Now, we've got a negative sign in front of the y that we need to get rid of. If you'll recall, we can fill that in with a 1, and that will allow us to divide by negative 1 and get y by itself. Now, whatever I do to one term on that left side, I have to do to every term on the right side. So essentially, dividing every term by negative 1 is not changing the term, just the sign of the term. So this 5 now becomes a negative 5x, and this negative 2 now becomes a positive 2. Now I have my equation in slope-intercept form, and I can easily pick out my slope, which is in the place of m, negative 5, and my y-intercept, which is in the place of b, and it's a positive 2. Okay, example 4. Example 4 says, graph the following equations in a coordinate plane. Now, if you will look at the equation in number 1, we have the equation that we need already in standard form. Remember, m is my slope, b is my y-intercept. So go back to those. M is how we move, b is where we begin. Excuse me. So if b is where we begin, that tells me negative 3 is where we cross the y-intercept. Okay, or the y-axis. So I'm going to come to my y-axis and I'm going to go down 3 units to negative 3. That's my first point. Now I'm going to look at my slope, which is positive 1/2, and I'm going to think about slope is the change in y compared to the change in x. So from my y-intercept, I'm going to count up 1 unit over 2 units, and I'm going to put my next point there. So now that I have these 2 points, I can graph my equation, and I could continue to make more points if I needed to, up 1 over 2, up 1 over 2. The more points I have, the more accurate my line would be. So this equation right here is y equals 1/2 x subtract 3. Now we're going to go through the same process for number 2. So b is where I begin, and that's a positive 4. So we're going to go to our y-axis, and we're going to go up 4 units and plot our point there. And our slope is -3. Now it's not a fraction, but we can easily turn it into a fraction by putting -3 over 1. And when our y value is changing -3, that means we're going to count down 3 over 1. Over here in number 1, we had a slope of 1/2, up 1 over 2. So from the y-intercept of 4, we're going to count down 3 units over 1 unit, and we're going to put our point there. Now if I wanted to count down 3 more over 1, I could have as many points as I want to make this line. And then line those up, put an arrow at both ends, and my equation for this one is y equals -3x plus 4. Okay, example 5. We're going to graph 2x plus y equals 2 and identify the x-intercept. Sometimes it's easier to identify the x-intercept after you've graphed it. So let's look at the form that we have here. Now there's a couple things that we could do. We can rewrite the equation and put it in slope-intercept form. Or we could also graph by our x and y intercepts, which we did in the previous lesson by substituting 0 for y to find the x-intercept or 0 for x to find the y-intercept. Let's practice both. So if I want to change this equation into slope-intercept form, I want to isolate y. So I'm going to subtract this 2x. Or you could say move it across the equal sign and change the sign. Same thing. Now I'm left with y equals, and let's go ahead and write this in the order we want. So -2x plus 2. Now we have it in slope-intercept form. And we have where we begin our y-intercept, and we have how we move our slope. So we can put that -2 over 1 and know that we count down 2 over 1 after we graph our y-intercept. So over here on the graph, our y-intercept is a +2 and we have a slope of -2. So we're going to count down 2 units over 1 unit. And again, I can count down 2 over 1 to make a more accurate line if I need to. And I'm going to connect those horribly, but that's what I would do with my straight edge, or on our Big Ideas math program, it connects that for you. Excuse me. Now this next part said identify the x-intercept. Once I have that graphed, I can see right here that my x-intercept, or where it crosses the x-axis, is at 1. So identifying the x-intercept, I could put that is equal to 1. Now, if you'll recall, I said we could also solve this by finding our x-intercept and our y-intercept. So if I'm finding the x-intercept, I'm going to replace my y with 0 And I'm going to solve this. So 2x, whoops. Sorry about that. Let me take that away. So 2x equals 2. Divide both sides by 2. And x equals 1. So my x-intercept is 1, which we already calculated when we graphed, or actually just determined where it crossed the x-axis at. So this ordered pair would be 1, 0. And we've already got that on the graph. Now, if I were going to find my y-intercept, I would substitute a 0 in place of x. Okay, anything times 0 is 0, and that just leaves us with y equals 2. So that ordered pair would be 0, 2, which is also already on the graph. So we could actually graph this one of two ways: by changing the equation into slope-intercept form and graphing with our y-intercept and our slope, or substituting 0 in place of our x and y and determining what the x-intercept and y-intercept is to graph as well.